Little review. If you're given x or b to the x is equal to a, that is equivalent to the log base b of a equal to x. Going from our standard notation, our exponential notation, to our log. And today is really day one with working with the natural logarithm. The common log is our LOG. And again, if they don't give us the base, it's understood to be 10. And today we work with a special kind of logarithm called the natural log. Why they went ln instead of nl, I don't know. But that is the natural log. And with the natural log, now if they don't give us a base, what is it understood to be? Yeah, I think I told you that once, but that is the natural log base e of 20. This is equal to the log base 10 of 20. And there is a direct connection between the number e and the natural log, because that's actually where the number e comes from. But again, maybe I can save that explanation in a YouTube video if I can find that for you. Natural log e to the x equal to a. It's the same format, guys. Okay, it's just going to be the natural log base e of a is equal to x. It's your common notation that we already know. Once again, the properties are going to be very similar. If I have e raised to the natural log base e of x, what do you suppose that's going to be equal to? It's just going to be equal to x. Remember the whole idea. If the base and the base are the same, then it's just equal to the of. We use that property with our common log. We can use it again with our natural log. Base and base are the same, it's just equal to the of. The other one that we had was when the base and the of are the same, it's equal to our exponent. Because in this, again, what's our base understood to be? E. Therefore, the base and the of are the same, it's just equal to the exponent. You did this with the common log. True. Therefore, same thing with the natural log. What's example 1a going to be? It says e raised to the natural log of p. What's your base understood to be here? E, therefore e and e are the same, therefore it's equal to the of, which is p. That is this property right here. The natural log of e raised to the 3c plus 1. What's my base understood to be here? E. Therefore, if your base and your of are the same, it's just whatever your exponent is. The exact same properties. We had the product, the quotient. You did that in the warm-up for number 2 and number 3. Those are going to be the exact same. We're dividing, now we're going to subtract those two. And what was our power rule? What could we do with that exponent? Yeah, move it down in front, correct? We could multiply by it. So that was equal to P times the log of A. Let's try natural logs since that's what we're working with today. Good to move on. Rewrite each expression as a sum or difference of terms, and then simplify if we can. Once again, you did this in the warm-up. Natural log of 6e. We're multiplying between those two numbers. So if we separate them out, we got to use the addition sign. And what is the natural log of e equal to? What's your base understood to be over there on the right? E. Therefore, your base and the other are the same, so it's equal to whatever your exponent is. What's your exponent? 1. So if you would like to put this in your notes, I think you already had it, but you can write it again. Natural log of e is always going to get you 1. Let's go ahead and try B. Here we're looking at a multiplication and a division all in the same one. You know, understand the fraction bar X is a grouping symbol, so the 3 and the e are together. So technically what we need to do is put parentheses around this, then subtract by whatever's left over. But we know that, well, those parentheses really don't do anything for us, so we didn't need them at all. But I want to put them in this step just because if you were to have two factors down below, it would most definitely affect it when you have two terms within the same parenthesis. Natural log of e raised to the 5x squared. You could use your inverse property at the beginning. Base and of are the same, so it's just equal to your exponent. But I would like to use my power property here. So I'm going to bring the 5x squared down times the natural log of e. And I know the natural log of e is 1. Therefore, 5x squared. Practice problems A, B, C, D, and E.